Okay, pre-calculus 10, here we go. We're going to further our journey with writing equations of straight lines, but we're going to look at a variety of different scenarios. It's going to involve algebra, it's going to involve arithmetic, and it's going to involve using all three of our lines that we know. So let's go. So let's make some connections here. Write the equation of a line that is parallel to 3x minus 2y equals 6 and goes through a given point. So if it's parallel, what does that mean? That means the new line we're creating has the same slope. So there's part one. And it's parallel to this line, 3x minus 2y equals 6, which means we need the slope. So let's convert to slope-intercept form. We're going to subtract 3x from both sides. And the interesting one with this is that we're going to now divide everything by -2. We don't even care about the y-intercept in this case. Now we get it, right? We get y equals 3 over 2x minus 3, but it doesn't even matter because all we need to know about this line that we're creating is that it's parallel to this one, which means this is the important piece of information, that my slope is 3 over 2. Because now what do we have, right? We know that we have a line with a slope of 3 over 2 and a point of 4 comma -2. And you can use either one. Let's use slope-intercept form here. So y equals 3 over 2x plus b. So what we need to do is we need to solve for b. So y is -2 in this case because I'm using this point, right? X equals 4 plus b. 4 and the 2 cancel, I'm left with a 2, so -2 equals 6 plus b. So b equals -8. So now we know the b, we know the slope, and we can write the equation of our line. Y equals 3 over 2x minus 8. So this is the equation of a line with a slope parallel to this that goes through this point. So you use almost every tool that we've worked on so far. Next example I do like this, I'll use point slopes just so you can see that it works with either one. So let's look at another. Write the equation of a line perpendicular. So this time we're going perpendicular. So again, we need the slope of this line. So we will subtract 4x from both sides. We get 2y equals -4x plus 7. And then divide by 2, divide by 2, divide by 2. Y equals -2x plus 7 over 2. So in this case, again, this is important, but since it's perpendicular, my slope is going to be positive 1/2 because it's -2 in the other line. So now I know my m in my new line is 1/2, and I go through the point -2 comma 5. So in this example, I'll use point slope. So y minus y1 equals m times x minus x1, and I'll plug in my x1, my y1, and my slope. So y minus 5 equals 1 over 2 times x minus -2. So y minus 5 equals 1/2 x plus 2. Multiply that in and continue. Y minus 5 equals 1/2 x plus 1, and then we'll just add 5 to both sides. And you get y equals 1/2 x plus 6. So this is the equation of a line that goes through -2, 5, has a slope perpendicular to that. So this is all about algebra mainly, and knowing which equation to use, but also knowing that you can use different ones as long as you use them properly. Okay, so now we have a little bit more detail. We know we got to finish in standard form, and we have parallel to this, and then same y-intercept. Okay, so what do we need? We need the slope first of this. So 2x minus 4y equals 11. I'm going to subtract 2x from both sides. -4y equals -2x plus 11. And then divide by -4, -4, -4. So y equals 1 over 2x minus 11 over 4. So it's parallel, so I need this slope. So I need that slope, m equals 1/2. And then the same y-intercept as this line. Well, the y-intercept is staring us in the face, right? This is the y-intercept. So I know I have the point 0, 5. So again, now, point slope or slope-intercept, since we have a y-intercept and a slope, let's just use slope-intercept because we know we have the same y-intercept. So y equals 1/2 x, and we know this is going to be a 5. So there's our equation, right? But that's slope-intercept form. We need to get to standard form. And rule 1 about standard form, no fractions. So multiply everything by 2. There, there, there. So 2y equals x plus 10. And we want x, y together, and we want x positive. It's already positive here, so why don't I subtract 2y from both sides? And now if you're paying attention, this is already in general form because the 10's already on this side. But since we want it in standard form, we just subtract 10 from both sides. We end up with x minus 2y equals negative 10. Nice, nice. Easy peasy. One more. Find the equation of the line in slope-intercept form. Okay, so now we need to finish in slope-intercept form. That is perpendicular. Okay, so perpendicular to this, which means let's find the slope. Minus 3x minus 3x. So negative 7y equals negative 3x plus 10. And then divide everything by negative 7. Y equals 3 over 7x minus 10 over 7. So if this is the slope of the line and we're looking for one that's perpendicular, we're looking for a slope that is negative 7 over 3. It has the same y-intercept as this line. So again, we need slope-intercept form again because we need to know the intercept. But this time, we don't really care about the slope. So if you just look at this, what do we have to do? We have to divide by negative 3. So this is the only bit that matters. We're going to divide it by negative 3, and we'll end up with negative 4. So that, right, because the slope doesn't matter. So then divide, we have a y-intercept of negative 4. So we have a y-intercept of 0, negative 4. And then easy to put it in slope-intercept form because we have the slope and we have the y-intercept. So it's just y equals negative 7 over 3x minus 4. Done, done, done. So knowing what you need to do is a good first start, and then doing it is a great end start. End start, great end. How about that? So that's it for a variety of scenarios. Look at the notes to supplement here, section 3.3. And just keep on going. You're doing great.